Joe Potter completed his undergraduate degree in economics from Yale University in 1968 and then spent 3 years in the U.S. Army during the height of the Vietnam War. When he left the Army, he entered graduate school at Princeton University, earning a 1973 Master's in Public Administration and a 1975 PhD in economics. After graduation, he spent a year at Princeton's Office of Population Research and then another year at the Population Council in New York, followed by 7 years on the faculty of El Colegio de Mexico in Mexico City. From 1983 to 1989, he was a professor of demography at Harvard, and since then he has been on the faculty of the University of Texas at Austin. Carl Schmertmann graduated from the University of Wisconsin with an undergraduate degree in economics and worked as an analyst for the Congressional Budget Office in Washington, D.C. for 2 years before going to Berkeley to earn his PhD in economics in 1988. He then spent a year as a visiting professor at the Brazilian Federal University of Minas Gerais before joining the economics department at Florida State University in 1990. Since then, he has been a research associate in the Center for Demography and Population Health, as well as spending a couple of years as a visiting professor and researcher at Berkeley and UT Austin. Susan Cavenaghi, originally from Brazil, attended the University of Texas as a graduate student and worked with Potter and Schmertmann on this paper. She later returned to a career in Brazil. All three scholars remain active in research on Brazilian population dynamics, including research visits to the country. Complementing Narayan Sastri's article on falling infant and child death rates in Brazil, this article shows us the other side of the demographic transition coin by focusing on falling birth rates throughout the country. The fact that patterns of fertility decline closely mirror the patterns of mortality decline revealed by Sastry shows the very close connection between these two strands of the transition process. Potter, Schmertmann, and Cavenaghi also demonstrate what they think is solid evidence that the process of modernization and development plays a key role in both of these demographic trends.
Narayan Sastry found Brazil to furnish an important recent example of mortality decline as part of its demographic transition. Potter and his colleagues found similar evidence in Brazil regarding fertility decline as the other half of that transition. Although infant and child death rates were already trending down in Brazil during the 1950s and 1960s, there was a slight delay of a decade or so before birth rates also started to decline. We can see here that the total fertility rate remained at around 5.5 expected births per woman over the course of her reproductive lifetime until the end of the 1960s. Fertility decline really got started and accelerated during the 1970s, falling to near the replacement level of about 2 births for every pair of parents by the early decades of the new century. It presents a particularly useful case to study for 2 important reasons spelled out by the authors. Both of these have to do with testing the common claim that falling birth rates, like falling death rates, are above all a result of economic development and rising prosperity. Most of the research that has advanced this possible link to development as an explanation for why birth rates fall comes from the excellent historical statistics available from a number of European countries. Both statistical evidence and falling birth rates have been around for a long time, and a lot of research has taken advantage of this fact. But Potter, Schmertmann, and Cavenaghi want to know whether the same linkage of fertility decline and economic development can be generalized to other parts of the world where birth rates are declining in recent decades rather than much longer ago in Europe. Do the same explanations still apply? This is particularly important because a debate actually has developed among scholars about whether the economic development explanation actually fits the facts of fertility decline in Europe itself. It is important to get some comparative perspective on the issue. Brazil also offers a good place for such research because in most countries where development and/or fertility decline are recent or even current events, detailed statistical evidence from the population is not always available or reliable. In a lot of countries, scholars have to rely on nothing but responses from 1 or 2 surveys conducted with a small sample of the national population. Good national coverage of reporting of vital events like births and deaths is often deficient in these countries, since such reporting tends to improve along with development itself. But in Brazil, census enumeration of the population was more reliable and covered the country relatively completely already by the time that fertility decline got started in the last third of the 20th century. The only exception to this reliable coverage is found in the remote interior rainforests of the Amazon basin. For this reason, the authors have less to say about these remote areas and concentrate their analysis, just as Sastry did, on the bulk of the population that lives along the Atlantic coast of the country. The article examines the entire span of time covered by the Brazilian fertility decline, comparing situations as depicted in the 1960, 1970, 1980, and 1991 censuses of the Brazilian population. These Brazilian census counts give us large enough numbers of women so that we can look at patterns and relationships for detailed geographic regions. The article actually constructed information about birth rates and possible predictors for over 500 small area microregions all over the country, rather than just results for huge areas like Brazilian states found in Sastry's article. Census data also makes it possible for the authors to consider many different possible explanatory characteristics at the same time, including women's educational attainment, their participation in the paid labor force, and even their experience with infant mortality. All three of these factors are often cited in other research as possible influences on birth rates. With more education and more paying jobs, women may have fewer births. If fewer of those births then fall victim to infant or child mortality, this can further reinforce the tendency to have fewer subsequent births as a kind of insurance against the fear of infant loss. Fortunately, all of the Brazilian censuses included questions about the birth histories of women, how many children they had borne, how many were still alive, and so on. These questions allow the authors to construct their birth rate measure, the total fertility rate, or TFR, from the question about births to women in the year before each census count, and also their measure of infant mortality, based on responses about how many of a woman's lifetime births were reported as still living by women at different ages. The TFR that they estimate from census data averaged an expected lifetime total of 6.3 births per woman in Brazil as a whole from the 1960 census, a level of childbearing clearly at the very beginning of the process of fertility decline. By the time of the 1991 census, however, this estimated TFR average in the country had fallen to only 2.7 births over a reproductive lifetime. While a TFR of 2.7 is still slightly above the replacement level fertility of about 2.1 births per woman, we can see that these four censuses capture most of the fertility decline that has occurred in Brazil. Potter, Schmertmann, and Cavenaghi also mention one more issue that they want to explore with these census results. The controversy over historical fertility declines in Europe challenged the idea that economic development was the key to such declines by pointing out that in some areas of Europe it looked like the conditions that went along with such falling birth rates were not primarily economic changes, but rather commonalities of cultural factors such as language barriers or a decline of religiosity among people. One telltale indication that economic development may not have been the main story, according to these critics, is that once fertility decline gets started, it can continue downwards towards replacement level fertility of about 2 births per woman, even if something happens to slow down economic development partway through the process. This is exactly what happened in Brazil. The period from 1960 to 1980, the first 2 decades between the censuses they study, saw strong economic growth and rapid economic development in the country. The third decade, from 1980 to 1991 censuses, however, witnessed a drastic economic slowdown. During this slowdown, do the same relationships between development indicators and birth rates continue unchanged? Or does the ability of the development indicators to predict birth rates weaken, as some other, perhaps unmeasured explanations take over and continue the fertility decline? Having these 3 decades to compare allows the authors to address this aspect of the debate over how to explain fertility decline. Census counts that they studied, and across the 3 decades between them, Potter and his colleagues expect to find the same usual suspects operating as causes of falling birth rates throughout their more than 500 microregions of Brazil. They developed measures of these causes based on the most widely documented findings from fertility research in other societies around the world. First among these is the problem of infant mortality. As Mason explained to us, one reason for high birth rates in most human societies of the historical past was that people were afraid of the deaths of some of their children. They often decided on having additional births as a kind of anticipatory insurance against possible infant loss. And particularly in cases when people actually did experience the death of an infant or child, the chances were then much higher that such women would quickly replace the lost birth with another one. Thus, in considering fertility declines all over the world, Mason concluded that the one most universal predictor of lower birth rates was a prior decline in infant and child mortality. As death rates go down, people have less to fear in terms of some of their births being taken away from them. Therefore, they don't bother any longer to have those insurance babies, and the birth rate falls. In the late 20th century, actual vital registration of birth certificates and death certificates for infants and children who died was not reliable enough to use throughout all regions of the country in constructing direct measures of births and infant deaths. Instead, they follow a complex indirect method developed by William Brass at the London School of Hygiene and Tropical Medicine some years ago. Brass discovered that if you know the ages of all women responding to a survey at the time of the survey, and if you find out how many children they have had and how many of those births are still alive at the survey date, you don't have to ask them for reports of exactly when the children were born or when they died. The information about ages and numbers of births allow you to estimate the ages of children as a function of the ages of the women. And the information about how many children have been lost by women of different ages allow you to estimate the death rates for infants and children at specific points in the past. It is this complicated estimation process based on census data that was used in this study to arrive at measures of infant survival in each of the microregions studied. At the time of each census, the authors expect regions with higher infant death rates to also have higher fertility, and regions with lower infant death rates to have lower fertility. Of course, infant mortality itself may have been responding to economic development as it spread unevenly across these Brazilian regions, as Sastry has already shown us. But Potter, Schmertmann, and Cavenaghi want to investigate other possible measures of development in addition to just the infant survival outcome. There could be other pathways that lead from development to lower births. From each of the censuses and from other Brazilian government records, they add additional information about each of the microregions to their statistical model. The example they talk most about in the article is the spread of electrification, extending power transmission lines across the country and branching out to provide electricity to homes and communities. They regard the arrival of electric power in a community as a kind of shorthand for many of the changes often described as economic development. So they expect to find lower birth rates following the spread of power transmission lines across the country with each successive census. Electrification serves as a gateway to and marker for consumer durables and the mass media. Consumer aspirations for durable goods and exposure to television had substantial unintended and synergistic consequences for reproductive behavior in Brazil, unquote. Also, like Sastry and his analysis of infant mortality, this study of birth rate decline also adds some personal characteristics of women themselves as possible measures of development. Of course, since they are studying the 500-plus microregions rather than records for individual women, Potter, Schmertmann, and Cavenaghi are using averages for each microregion rather than details about specific women. For example, when they consider women's education, the measure that they include refers to the share of women throughout one of these microregions with different levels of education. The idea behind this is that with more education, women on the whole should be more likely to marry later and have fewer births later in their lives. Delays in marriage and childbearing with more education could be due, of course, to the related idea that women with more education are also more likely to have skills and ambitions that result in their participation in paid work outside the home. For this reason, the authors also measure the share of women with paying jobs in the different microregions. If this measure shows a link to birth rates, and the education measure also still shows such a link when both explanations are included in a statistical model, this would suggest that education may also have other delaying effects on birth beyond just its association with paying jobs. For instance, more educated women could develop new interests and perspectives that include alternatives to parenthood as an adult role. Potter and his co-authors then put all of their explanatory possibilities into a single predictive statistical model and looked to see how well each of these explanations actually lines up to predict differences in birth rates across the microregions of Brazil. Their figure 1, showing a map of changes over time in the total fertility rate, gives us a good picture of the process of decline in birth rates in the country. Looking across the top panel of the figure at rural areas, we see clearly that the first signs of lower TFR values appear at the extreme southern tip of the country in the 1970 census. By 1980, the lighter shading indicates lower TFRs begin to spread up into the rest of the south and southeast regions, and by 1991, we can see that the rural parts of this entire southern part of the country are in the lowest categories of recorded births. The fertility decline even begins to spread up into more northern rural areas. Note that in 1960, the first census does not include information for the extreme north of the country, where rainforests and sparse population made it impossible to collect accurate census results. These areas have no data at all for 1960, not low levels of fertility. In the bottom panel of the figure, we see essentially the same south to north spreading pattern of fertility decline, with one important difference. For urban areas in this bottom half of the figure, the whole process of fertility decline appears to be running about 10 years ahead of the rural pattern. Thus, if you compare the maps for 1970 urban areas and 1980 rural areas, the pattern of shading is almost the same. Similarly, the 1980 urban pattern looks almost the same as the 1991 rural pattern. This lag of rural areas behind urban areas implies that measures of development also should lag about a decade behind in rural areas. If that turns out to be true, it would mean that these measures of development could be good predictors of fertility decline in both rural and urban areas. The development lag would explain the lag in fertility decline. For this reason, the authors show us changes from census to census in the geographic pattern of electrification across their rural and urban areas. Sure enough, we find the same south to north spread over time as observed for the birth rate decline, and we also see the rural pattern lagging behind the urban pattern. As a matter of fact, the rural lag in electrification appears to be even longer than the lag in birth declines. The urban pattern of electrification by microregion from 1970 looks very much like the rural pattern that we find 2 decades later in 1991. So we can realistically expect that across all these decades of census results, the development indicators might well do a pretty good job of predicting local birth rates across the 500 plus microregions of the country. We turn next to their actual findings and conclusions about this predictive power of the development indicators. The article presents the main findings of Potter, Schmertmann, and Cavenaghi about what predicts high or low total fertility rates in different microregions of Brazil. Down the left-hand column of the table, they list all their considered predictive measures. The first of these is their estimated measure of child mortality, the same risk of death between birth and age 5 considered as an outcome to be predicted by Sastry in his article. The second is the extent of electrification in each microregion, and the next two are measures of female labor force participation and years of formal schooling for women. The last measure they consider is the percent of people in each microregion reported as being Catholic in each census year. This is a measure we could never consider in the United States because the constitutional separation of church and state has been interpreted legally to mean that the government can never ask any questions about religion on census forms or other government documents. They include this measure in order to consider alternative ideas from the debate about why birth rates declined in Europe. Are birth rates in Brazil predicted by economic development or by religious change? Of course, economic development and religious change may themselves be closely linked, but that is another question for another day. Finally, this table 2 shows different constants from their estimated statistical models for different census years. If fertility declines between each pair of censuses were due to a parallel process of changes in the development indicators, then such indicators should work in essentially the same way across models compared for different years. Development indicators might work really well to explain fertility decline during the first couple of decades, when development itself proceeded quickly, but then do much worse to predict lower fertility in the last decade. That is, if fertility kept falling, even in places that no longer were developing much at all. If the model worked differently in different decades, we would expect to see differences in the constants of these models. So, what did they find? First of all, the coefficient for child mortality is positive. This means that in microregions where child mortality is higher, estimated birth rates also tend to be higher. This is just what we would expect if people are having extra babies when they fear that some of their earlier children may not survive, or when a child already has died. This link between childhood deaths and high birth rates was stronger in rural than in urban areas. Second, the coefficient for electrification also predicts TFR values. The chance that this observed link could just be due to random fluctuations is near zero, as shown by the significance measure in parentheses after each coefficient. If this chance is below 0.05, we conventionally accept the predictive power of the considered explanation as a real and significant effect. More electrification predicts lower birth rates, as shown by the negative sign of the coefficient. This effect also is significant in both rural and urban areas, but this time the effect is slightly stronger in cities than in the countryside. The share of working-age women with paid employment outside the home also shows a significant negative relation to TFR values, meaning more jobs for women predict lower birth rates. But this time the result is only significant in urban areas. The coefficient for rural areas is much smaller, too small to be considered reliable as a real effect. As expected, microregions with more educated women also tend to have lower birth rates, and these coefficients, though they are not as large as some of the other coefficients in the model, are significant in both rural and urban areas. So far, all the usual suspects from development theory are working well as explanations of variations in fertility across the microregions of Brazil. Looking beyond measures limited strictly to economic development theory, the authors find that areas that have more Catholics also tend to have higher birth rates, at least in cities. The coefficient for this factor is large, positive, and statistically significant in urban areas. However, this factor is not significant in rural areas. There is a 38% chance that the observed coefficient could in fact be due just to random fluctuations across the regions. For this reason, we shouldn't waste much time looking at the negative sign on this coefficient. Most likely it does not mean anything given the low level of significance of the result. Apparently, if birth rates are declining faster in Brazil, where there are fewer Catholics, this is only true of urban areas and not the rest of the countryside. Finally, Potter and his colleagues observed that the constants for different census years remain about the same in their model, estimating a starting point for TFR values around 5 or 6 children per woman before we start adjusting this estimate for all of the considered influences. This constant is what the total fertility rate would have been in the absence of the effects of all these predictive factors. In other words, without the development that actually took place in the country. The fact that these constants look about the same across all their models tells the authors that their model is working in pretty much the same way across all 4 censuses, including decades when development was running at full speed, but also when it slowed down dramatically between the last 2 census counts. So what do Potter, Schmertmann, and Cavenaghi conclude about fertility decline in Brazil, based on these facts and figures? Do more education for women, electrification, and other infrastructure improvements, and better child health and survival, in short, economic development, predict lower total fertility rate values? The answer they found says yes. Furthermore, do these development indicators weaken over time as predictors of fertility levels across Brazil's microregions? This time their answer is no. Economic development seems to be the dominant explanation that does a pretty good job of explaining fertility decline in Brazil over the entire span of these 4 census counts during decades when Brazil completed most of its fertility transition.